So last time we talked about spheres, and after spheres, there are some other useful shapes. Quadric, which is cylinders. I think I think cylinder is useful as a light source.
I mean, there's lots of long tubular light bulbs,
Yeah,
so maybe.
centered around the z-axis, and the user can supply a minimum and maximum z value, as well as a radius r and maximum phi sweep value. This immediately make, I feel like this will make the thing much more complicated. But anyway, a cylinder is described by the following equation. Phi is U phi max. What is U?
Is that UV coordinate?
Yeah, I think it's probably just how they map the texture onto the cylinder. Yeah, yeah. So like 0, 0 here and 1, 0 here. They didn't show V though. But I think V is mapped from, yeah, it's here. V is mapped from Z.
Yeah, it doesn't have any cosine or sine, so it's much simpler.
Yeah. Well, we still have cosine sine to
Yeah, but
app
not for
for,
the V
yeah,
parameter. I
yeah.
mean, this is like the was it the equation for a circle, but parametrized.
Yeah. And a circle is much simpler than a sphere. So yeah. This is like middle school level stuff. Like a sphere is like high school level. So at least from my education background. Similar to sphere, cylinder constructor takes transformation there. And the parameters define the cylinder itself. Those two are just inverse. Reverse orientation, this is the same as sphere. And this is just bunch of parameters for those. And they're stored in here. Area is straightforward.
Flashbacks to calculus class where they're trying to measure a cylinder that's actually like the area is constantly changing, so you have to integrate over the changing circle in like a
Oh, yeah. You still remember that? Like, if you didn't mention that, I completely forgot about that.
well, when it's the AP test and you get like, everyone in your class afterwards are like, "Fuck that problem. Oh, it was so hard." stands out in my mind.
Yeah, and bounds is also straightforward. Normal bounds, again, it's just conservative entire sphere. I think normal bounds will only be interesting when we deal with stuff like triangles.
Yeah, or uh,
Intersection test, similar to sphere, cylinder provide a basic intersect written on quadric intersection and then interaction from intersection. Yeah. And the basic intersect method also parallel to spheres. Compute the quadratic coefficients of the quadratic equation and then handle varicase for partial cylinders. Yeah. As before, the fragment also compute the quadratic discriminant. Okay. Ray cylinder intersection formula can be found by substituting Ray equation into the cylinder's implicit equation. Uh, X squared plus Y squared minus R squared. Yeah, that sounds right. But this does not have the top.
no, it
Or
does not.
yeah, they probably just doesn't have top, just the cylinder only have sides. I don't know.
Maybe that was just a goof in the printing.
Or maybe they will deal with the top and bottom separately or something.
Or maybe it does not have a top and a bottom. Because
Yeah.
like this circle is, it's x plus y minus r, all individual things are squared. And so like it's the implicit equation for a circle um augmented by a radius.
I just feel like a shape that is watertight is much easier to deal with,
Yeah.
and there
It
it's probably likely to be physically correct. So I don't know.
yeah, also their bounds equation implied top and bottom, whereas if it was
Yeah.
just a cylinder, then they could, do a circle pointed outwards. Or a disc, I guess. Anyways. Oh, that's an
Anyways,
infinitely long cylinder.
well,
Oh,
but then we can, yeah, we can just do this and then clamp it.
I
Then
didn't
we have
read the
intersecting
implicit.
point
I,
here.
I didn't I didn't read the infinitely long part, and so I was like, how does it know when to stop? But
Yeah. Anyway, substituting the equation, we get this. And then we expand it, we get our quadratic equation, A and B and C. Result is the same as a sphere. Next step in the intersection method, make sure the heat is in the range because that was infinite. And the angle is acceptable. If not, they reject the heat. Yeah, so if and the intersect piece implementation is just a simple wrapper of basic intersect. Interaction from intersection. U value is just computed by scaling phi to between 0 and 1. And V value is, yeah. Is this like inverse lerp?
I think it's just a scale.
Yeah, I think this is inverse lerp.
I mean, it's you divide by the range, subtract the max.
We'll just put it here. Anyway. Also, we compute some derivatives. I don't like the writing when this is something easy because it is often not. I guess in this case, it's pretty easy though. It's just from the, yeah, from this. we again use this thing that I didn't understand last time to compute the parametric partial derivatives for cylinder normals. Anyway, uniform sampling for surface area of cylinder is, wait, they seriously just, the cylinder just don't have top and bottom, I think. It's just like this.
That's that is in if you're trying to do a light that is like a tubular light, yeah, I guess you don't really need the end caps. But also, yeah, that's very odd.
Yeah.
It's a heck of a lot easier to do a texture map onto a cylinder without a top and bottom. But
Oh,
that's
I
about
guess,
all.
yeah. I guess if you want top and bottom, you can just put two spheres at top and bottom.
Oh yeah.
Sampling, they really like to say this kind of, this is easy, this is straightforward. I don't like this kind of writing. Uniform sampling, the height and phi gives you, give the uniform area. Yeah, yeah, because it's just a row of rectangle. Yeah, that's much easier than the sphere, at least. So I guess they can say it's straightforward. Uh, they get you day and phi, and then yeah, they use inverse lerp again. So that's why like Fourier said this is a function often overlooked. Just we do this kind of calculation all the time, actually. Given the and phi, the object space position normal are easily found. Oh, yeah, sine, cosine. Okay, normal is just derived from object position.
Yeah,
That
the
makes
X and
sense.
Y, the circle.
Yeah, yeah, and this zero.
Where does
Because
reverse orient? Sorry.
what do you want to say?
Where's the reverse orientation come from? I must have missed
It's
that.
it's just passed into the constructor.
Oh, oh, it's like
Yeah,
the a cylinder that's inside out or something.
yeah, it's the same as sphere. Like you want the normal to point inward or outward.
Uh-huh.
And the PDF is just uniform. Unlike sphere, cylinder does not have specialized solid angle sampling method. That makes things much easier. Both sample and PDF methods can be implemented using the same fragments that were used for solid angle sampling of reference point inside spheres. All right. But I didn't understand this part last time, so I don't know. Let's just assume it's working.
Yeah, I'm more interested in how they're gonna do triangles anyhow.
Yeah, I guess this is a short chapter, so let's end it here.
Well,